So students, we have seen the concept of factor. We understood that factor is basically a function which is used to find out the distinct values in a vector. We have also seen that how many levels are there in a factor, and we can also define our levels in a vector with the help of levels attribute, and then that levels attributes overrides the actual levels which are present in the factor. Now, there is a very tough question that if I want to check a particular factor in R, I want to know that particular factor is present in R or not. And the function to understand this is called as is.factor. So there I want to know, it is used to check whether the variable is a factor and returns true if it is a factor. So basically, if we want to know that a particular variable is a factor, which means that all the values are unique or distinct in that particular series, is called a factor. So if it is a factor, we will be calling it a factor, and is factor function will print true if that particular value is a factor. So you can see the code here. Gender equals to factor, and factor, in the factor we pass a C function where female, male, male and female are passed as parameters, and we are now printing is.factor and within brackets gender. So what happens here? In this we see is factor gender. Now since gender is a factor because it has stored the factor values of the vector C, and therefore the output is true. So this is how we are checking for factors in R. If suppose I want to check whether this particular variable is a factor, I will just write is.factor, which is my is factor function, and I am checking is factor, and I pass the parameter which is a factor parameter. If it is a factor parameter, it will become true. So this is how I can do little bit of programming on my data, where I can find out whether a particular value is distinct or not. We have also seen in this lecture the concept of matrices, where we are storing the data in the form of rows and columns. We also saw that how we can pull the values from the matrices with the help of indexes, where we are just writing the name of the matrix and in the square brackets row, comma, column, address. Like that, we have also seen slicing over here, that with the help of slicing, I can either pull an entire row or an entire column, or project a particular column on the screen and see that as output. So that is how we are trying to access the values from a matrices. Like that, we have seen vectors, and then we apply factors on the vectors to find out the distinct values from a particular list of values. So you can see that when there is huge data set, in that case, we require such kind of robust functions to work on the data so that we can have a meaningful insight on the data, that what this data is trying to convey or what this data is storing. And sometimes we have to treat the data in the form of data frames, or we can say in the form of database. And there definitely I want to impose a query on the data. And in that case, I will either pull a particular row as an output, or a column as an output, or maybe a particular cell's value as an output. So all these robust features are present in R. And in the next lecture, we will be learning some more constructs of R. I hope you all are able to understand the basic concepts of R. Thank you.